So I got a question on the forums recently about this kind of construction. It got me curious, so I figured out how to do it and thought I'd make a quick video. So the question was asking about, if we had a couple of curves like this. So these are two curves here in 3D, two splines out there, right? This spline and that spline. And the question was, if you created a plane intersecting one of the curves, and then you measure from that intersection point to the second line, right? You can do that certainly, but then you want to pattern the plane, the intersection point and the measurement feature, and get different results for the distance from the first curve to the second. And the question was, how could you do that in NX? The measurement, the trick there is the measurement doesn't like to be patterned, right? In that it needs new geometric inputs, of course, along the way. It needs a new point for each of those along the way there. And so with regular features, I'm not seeing an easy way to do it right now, but as you might have guessed here, with an algorithmic feature, this is pretty straightforward. So the end result here is going to be this kind of a thing, right? Where, for instance, if we had a point set along that curve, say with 10 points, right, or 9 divisions going along there, we're doing essentially a minimum distance from each of those points to the adjacent curve. And we get that kind of a result, right? So what I'm going to do is go back and build this algorithmic feature. We can build that from scratch and see what that looks like, okay? And it'll also help a little bit with the process of building an algorithmic feature. So we'll do that. So we'll start with these two splines right here in the model. I'll leave that one there just turned off for now, and we'll build a new one here, kind of right next to it. So algorithmic feature lives in here, right? Inside the home in the more, and so this is going to fire up the environment here where we can build that. We'll have the model down below. We'll pick those curves in just a minute, and we'll start to build the logic graph up above. This is actually from building it before. I've still got the output node up there, so I'm going to double click that and stick that over here on the right. We're going to end up with some output, right? That'll be those lines going across there. But then let's start to build it here. So I'm going to search on select, and I'm going to grab select curve, because we need to select kind of that first curve and select the second curve down there. And this first one here, let's change the name of this to be the kind of the driving subdivided curve, right? Divided curve. There we go. And that's kind of a long name, but I think that'll still work. It's a little long. Yeah. Well, let's edit that again. Let's call this. We'll just call it the subdivided curve. There we go. That's fine. And then this second one here, let's call this one for the curve for projection. Okay, and that's a clue as to how we're going to do this actually. But so with that, we've got our two curves that we're going to select, and then what we're going to do is subdivide this first one. We're going to put some points on that curve, right? So I'm gonna type in point, and let's do points actually, and that'll get us points on curve. Double click that. That'll bring up our points on curve block. Okay. Now this guy here, what we can do is connect that curve to that curve, and that's going to start to do it. It's telling us it's not quite resolved yet, right? All the node inputs are not connected. We still have a red one there. The divisions here, we can MB3 if we want to on any of these and say create input, and that'll actually create that kind of an input for us. This is a numerical input. This one we'll type directly into the feature dialog. If we want to, we can make this an expression input if we want to, right? I'm not going to do that in this one, but anyway, this will be our number input. This is divisions in here, so we want to end up with 10 points, so we want 9 divisions here. And let's divide that by what? Let's divide that by arc length. Yeah, that looks right. So let's do that. So we've got kind of our points on curve there, and we're going to select this one in just a minute. But with that, we should be able to preview these out there and see those resultant points. So do we have? Oh, we haven't selected the curve yet. That's why this is still red. So let's go grab that. We can select that curve as the input, and now we've got those inputs, and now we can preview and see those points out there. So let me turn off the preview here. So that's the points along the first one, right? Now the trick here is this middle one. So instead of using a measurement here, we're going to use project a point onto a curve, which really does the same thing. This is going to get us a minimum distance from the point to a curve. And so the points we're going to start with here are these points, and the curve is going to be this other curve here that we'll select. Oops, I missed. There we go. And we'll select here the second curve. Okay. And that will project those onto that curve, right? And here again, we can preview those, and it'll tell us those are the projected ones. So that's pretty cool. So we've got those ones on the first one and those ones on the second one. Each of these, of course, is a list. This first one is a list of 10 points. And here again, these 10 points came into this node, and so it's doing this one 10 times as well, and so we get 10 points out of this one as well, right? Now, we've got these points here that are going to be the start point for a line, and let's grab a line node, and those ones that are going to be the endpoints for that line node. Let's just, for the sake of lining it up a little better, let's put those as the start point and those as the end point, just because we can. And that then, if we preview that one's going to be that set of lines right there, which is pretty cool. And then, of course, we can pipe that line to our output. So this is the line here at the end is the only thing that gets output. We're not going to output those points along the way out there. But that's the basic construction, right? So we select a point, we subdivide that curve 9 times to create the 10 points, and by arc length. And then again, that's going to create the points. And we're going to ignore the vectors and things. We don't really need to use those in this case. We'll use those points, project those points onto the second curve, and then create lines using those as the start and end points, right? And send that to the output. We can go to our properties over here, and we can call this let's call it like our projected points ladder, because it kind of looks like one. There we go. Wow, I'm typing well today. There we go. Good. And we could add some description there if we want to. We'll say OK, and with that we'll save this, and that'll save that into the part. Actually, we don't need to save. If we want to save it out, we can save it out into a separate file, but actually we can just finish here, and it'll save this feature into the part. So that will create this guy in here. It's our algorithmic feature, right? And then and the lines are out here, of course, right? You can see those highlighted as we select that. And if we edit this guy, we'll get that name that we put in. We've got the select subdivided curve, the number of subdivisions in here, and the divide by arc length. So if we want to jack this up now and say we want to make this, say, 25 or something like that, we can do that, and that will do that one instead, right? So this becomes now a feature that we can use to build stuff on, and that works really well, right? Now, just to kind of prove out the concept a little bit, I'm switch that back to 9. So we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines now. Yep. And just to prove out the concept here, if we, for instance, go to here, let me grab this one and do a point set, and kind of approach this manually, right? If we did 10 points along this curve, we can see we've got those same 10 points there. And I'll go ahead and create those. And then let's look at the measurements here. This is the part I wanted to verify, and I'll do this with you here. We're going to measure between that curve over there. I've still got that on point from before. Let's grab that curve over there as our object 1. And for our object 2, let's pick a point. I'm going to filter on point and pick that first point right there. And we'll see there that minimum distance arrow or extension line there is of course following right along that line that we had picked, right? Now, this is a little measure trick. I can go back to that object 2. I'm still filtered on point, and I can pick that point, and it'll verify that one. Sure enough, that's lining up, and that one's lining up, and that one is, and that one is, right? So we can kind of walk down along here, and we can verify that these lines projected onto the curve, sure enough, are doing the minimum distance like we expected, right? And again, that reselecting that one in the list lets us go and quickly just look at alternate measurements, replacing that second point in the measurement, which is pretty cool. It's a nice technique. So with that, we cancel that. We don't actually need that point set either. I can delete that one. The other thing I was going to do here was, yeah, we can edit this curve, right? Go back and edit this original spline just to show that it's actually associative there. So we can grab, say, a couple of these guys, move those around a bit, and see that that's updating, of course, right? Again, 3D curve. Yeah, it's 3D now. It was kind of 2D-ish before, but it's pretty 3D now, projected onto this guy. One caution here, just as if you're doing this particular technique, is if this one's much bigger than the other one, then you may end up with a couple, converging. The nearest point for those two might be the same point at the end point there, right? So if you're wanting to keep those separated out there, you can either make this one shorter, right? Or the alternative, of course, would be to take the other one and overbuild this other one here to get those to spread out nicely. Okay. So anyway, yeah, interesting technique there. A little bit of walkthrough on the algorithmic feature. Of course, if you want to edit this one, you can edit parameters or edit with rollback, either one, and we'll get the dialog, right, that we created inside there. Again, those renamed nodes show up as the selections here for these guys. We could rename these others if we wanted to as well, but we didn't. That properties inside there let us set the name of this particular dialog. And if we want to edit the algorithm, we can do that too. We can come in and do this edit definition, and that'll launch us back into the logic editor here and allow us to do that kind of editing too. Okay, so hope you find that useful.